Section 1.2 is on solving equations in one variable, and in part A, what we're looking at doing is solving equations in one variable. In example 1, we want to determine whether a number is a solution to an equation. Specifically, we want to determine if 2 is a solution to this equation. So I'm going to start by substituting 2 in for each of the variables. So I start with 2 minus 4 times 2. And I want to know, is that equal to 3 times 2 minus 4? So we're going to simplify both the left and the right hand side and see if we get the same thing on both sides. First, 2 minus 4 times 2 is 8. So I have 2 minus 8. That's negative 6. And let's check to see if that is the same thing I get on the right hand side. On the right hand side, we're going to use order of operations. That's 3 times 2 minus 4 is negative 2. And I get negative 6 from 3 times negative 2. So my answer, that check mark means I have yes here. So my answer is yes, 2 is a solution. In part B, I want to check 5 in the same equation. Is 5 a solution to this equation? So we've got 2 minus 4 times 5. Is that equal to 3 times 4, or 5 minus 4? So on the left-hand side, that would be 2 minus 20, which is negative 18. Is that equal to, that's 3 times 5 minus 4 is 1, which is 3, so that's no. No, 5 is not a solution. Now, these types of equations that have one variable, no power on the variable, will only have one solution. So if you identified one number that is a solution, no other number should work. Just a note. A number is said to be a solution if the equation becomes true when the number is substituted for the variable. And the method for solving a linear equation is to follow one of the most basic laws of algebra. Whatever you do to one side of the equation, also do to the other side. Right. And I'm going to do that using the addition property and multiplication property of equality. The addition property says that if A is equal to B, then you can add the same thing to both sides. So A plus C has to be equal to B plus C. That is, we can add, or I'm going to put in parentheses subtract, since addition and subtraction are really the same thing. If you add a positive number, or if you subtract a positive number, it's subtraction. So adding a positive number would be addition, adding a negative number would be subtraction. So add or subtract a value to both sides without changing the solution. Right. Multiplication property, same thing, except for multiplication. If A is equal to B, then A times C has to be equal to B times C. So that means that we can multiply, or again divide, since multiplying by a whole number is multiplication, multiplying by a fraction is division, by a value without changing the solution. So if you go to the next page, we're going to see some examples using the multiplication and addition properties. Okay, so in example 2, here we have x plus 8 is equal to 2. I know I can do the same thing to both sides using that previous statement. I want to get x by itself. Right now it's x plus 8. I want to get rid of the 8, so I'm going to subtract 8 to both sides. That's going to leave me with x equals, since 8 minus 8 is 0, I have just x on that side, and 2 minus 8 is negative 6, so x equals negative 6. Okay. In part B, the variable is on the right-hand side. Doesn't matter if it's on the left or the right. I'm going to find the variable and work away from it. And minus 7, so I want to get rid of minus 7. The opposite is going to be plus 7, so I'm going to add 7 to both sides of the equation using the addition property. So 4 plus 7 is 11. That gives me 11 equals n. In the next one, I have 1/3 equals x. I'm sorry, 1/3 plus x equals negative 4/3. So to get x by itself, I want to subtract 1/3 from both sides. So that gives me x equals, and in order to subtract 3/4 and 1/3, I need to get a common denominator. So I'm going to have to multiply by looks like if I multiply by 3 and by 4, I can get 12. So top 1 times 3 on both top and bottom 1 times 4 to get a common denominator 12. That'll give me negative 9 twelfths minus 4 twelfths. So my answer is going to be negative 9 twelfths minus 4 twelfths gives me negative 13 twelfths. So x equals negative 13 twelfths. Now, it is important to note that negative 13 twelfths is an improper fraction. We always want to leave our fractions as improper numbers in algebra rather than converting them to mixed. We never convert them to mixed unless we're working in a story problem. We want to leave them improper. In part D, this is our first use of the multiplication property. Right now I have x divided by 7, so the opposite of divide by 7 is going to multiply by 7, and we're going to do that to both sides. 7 divided by 7 is 1, so I have 1x, or just x, equals, and 9 times 7 is 63. In part E, it starts off with a multiplication of negative 5 times x. The opposite of multiplication is going to be division, so I'll divide both sides by negative 5, which gives me x equals negative 6. And part F, this is a multiplication by 5 6, so I would want to divide 5 6, but I know that when I work with fractions, dividing by this fraction is the same thing as multiplying by its reciprocal. So we're going to multiply both sides by 6/5, the reciprocal. That allows 6 and 6 to divide out and 5 and 5 to divide out, so I am left with y equals. And then when I multiply two fractions together, you can reduce the top and the bottom, any top with any bottom. So you can reduce the 6 and 8 to 3 on the top, 4 on the bottom, and then finish the multiplication. 3 times 3 is 9 across the top, 4 times 5 is 20 across the top, so I'm going to end up with 9/20. Let's flip over a page. Okay. Sometimes there's more than one thing to undo to isolate the variable. In these cases, we want to keep the following steps in mind. The first thing that you would want to do to any problem is remove parentheses by using the distributive property if necessary. Next, you'd want to get all the terms that have the variable on one side, so we always do the variable first, and then get all the terms that don't have the variable to the other side of the equation, so constants next. Finally, use the multiplicative inverse. So both of those are additive inverse. We do our additions and subtractions before we do our multiplications or divisions. Okay, because we're doing the opposite of both sides, we're also doing the opposite of the order of operations here. So in example 3, when I want to solve, there aren't any parentheses. I already have the variable in one spot, so I'm going to go right ahead, getting all terms without a variable to the other side of the equation. So I've got my plus 2, I'm going to have to subtract that from both sides. That gives me 7x, since 2 minus 2 is 0, it's gone, equals 3 minus 2 is 21, and then I can solve for x by dividing both sides by 7. So 21 divided by 7 is 3. So x is 3. In part B, I want to get the variables together first. 3x and negative 5x are on the same side, so I'm just going to combine them. I don't need to do any opposites unless I'm moving it to the other side of the equal sign. So just do 3x minus 5x gives me negative 2x plus 2 equals 3. That was a simplified step, not one of the solve steps that I needed an opposite for, since they were already on the same side. Now, I want to move 2x to the other side. That's when I go ahead and use opposites. By subtracting 2 to both sides, I'm going to effectively move that to the other side, and I'm going to get my negative 2x equals 4 from 6 minus 2, and then I'm going to divide both sides by negative 2. So that's going to give me x equals, so divided by negative 2, so 4 divided by negative 2 is negative 2. Okay. In part C, I want to get all the variables on the same side. I've got a 2w on the left and a 6w on the right. I can either move my w's to the left-hand side or my w's to the right-hand side. It doesn't matter in terms of solving. A lot of people like to move the variable to the side that has the larger coefficient because you have fewer negatives. Let's go ahead and try that technique here. So I'm going to subtract 2w since that one's smaller. That's going to keep negative 9 on the left-hand side and give me 6w minus 2w is 4w plus 23. Then, to get rid of the 23, you have to subtract 23 from both sides. You want to work away from the variable, trying to separate the number from the variable. And negative 9 minus 23 is going to give us negative 32. equals 4w. And if you divide both sides by 4, negative 8. W is equal to w. 32 divided by 4 gives me 8. So I've got negative 8. In part D, this one has a couple of distributes to do. So I'm going to start by distributing negative 4 across the first parenthesis. So we've got 5 minus 8x. And then two negatives are going to make that plus 12. Equals, second distribute, it's going to be 12 minus 3x. Okay. Now I've got two different sets of variables here. So let's go ahead and get them on the same side. I can do either one. So I'm just go ahead and add the 3x to both sides. So this one I'm just moving my variables to the left. And that gives me negative 8x plus 3x. That is going to add up to a negative 5x. And while I'm working on this side, I'm going to go ahead and combine my like terms. 5 plus 12 is 17, so I'll say plus 17 equals 12. My x's are on this side, so I need to get rid of the 17. So I'm going to subtract 17 from both sides. So it gives me negative 5x equals, and 12 minus 17 is negative 5. So now I'm ready to divide both sides by negative 5 to get x by itself. So I've got x equals, and negative 5 divided by negative 5 is a positive 1. Okay. Now for any of these, we could check by plugging the solution back into the original equation. So let's do that with this one right here. So if I check, that's going to be 5 minus 4 times 2 times 1 minus 3. And I'm going to check that that is equal to 3 times 4 minus 1. So first, let's get our parentheses simplified here. That's 5 minus 4 times. That's 2 times 1 is 2 minus 3 is negative 1. So that's negative 4 times negative 1 is positive. So it's going to be the same thing as 5 plus 4, which is 9. Let's check the other side and see if we get the same thing. Okay, so inside the parenthesis, 4 minus 1 is 3. So that's 3 times 3, and 3 times 3 is 9. You can see that they check. Therefore, we know that we have the correct solution. So it's always a good idea to know how to check your answer to make sure that you have the right answer. You can also check on the calculator. I'll show you that real quick as well. But anytime you're on a test, you want to make sure that you have the ability to check your answer. So if I just on the calculator do exactly like it looked, parentheses 2 times 1 minus 3 close parentheses, you can see I get 9 for that side, and also we had 3 parentheses 4 minus 1, so I should get the 9 on that side also. So it's maybe a little faster to use the calculator to check. All right, let's look at the next page. So we have one more page in this section. All right, example 3 continued. A few more equations to solve. We've got some distributes to do. So first, 2 times 3x is 6x, plus 2 times 4 is 8, minus, I'm going to distribute that negative. It's going to make that minus 4x and plus 1 from that negative times that negative. Equals, another distribute, so 3x plus 3 times 2 is 6. Draw a nice line there. And combine like terms. 6x minus 4x on this side is going to give me 2x. And 8x plus 1 is going to give me 9. Equals 3x plus 6. It's often common to move the smaller variable if there's more than one. So I'm going to move the 2x. It's going to leave me with 9 equals 3 minus 2 is 1. I don't need to write 1x. I can just say x plus 6. And then we'll end by subtracting 6 to get the x by itself. Get rid of the plus 6 with a minus 6. So 3 is equal to x. In part F, I want to solve for this variable k. The very first thing I need to do is add 3/2 to both sides. Now, since these don't have a common denominator, I'm going to need to get a common denominator before we continue the addition. So I'm going to get a common denominator, which is 6, by multiplying the top fraction by 2 and the bottom fraction by 3. So that gives me 14/6, and it gives me 9/6. So right now I would have 5/6 k equals 14 plus 9 is 23/6. Okay. then I would divide by 5/6, which is the same thing as multiplying with the reciprocal, which is 6/5. Okay, so your 6 and 6 would divide out, your 5 and 5 would divide out. If I reduce over here, my 6 and 6 divide out, and I end up with 23 times 1, which is 23, over 6, I'm sorry, there's a 1 right there, 1 times 5, which is 5. So the answer to this one should be 23/5. Now, I want to go ahead and redo this question because fractions kind of bug a lot of people, so I want to make sure that we're extra clear on this one and show you another way to do it as well. This second method is going to be called clearing the fractions. A lot of people like to just get rid of those fractions. And you clear the fractions by multiplying by the least common denominator for all of the variables, or all of the fractions, I mean. So let me go ahead and just write the problem down first. It was 5/6 k minus 3/2 equals 7/3. That's before I did anything to it. So the least common denominator for all of these denominators would be 6. So to clear the fractions, we're going to multiply everything by 6. So it's going to be 6 times 5/6 k minus 3/2 equals 7/3. And we're going to make sure that least common denominator, that 6, multiplies into all of our fractions, all 3 parts in this equation. So first, 6 times 5/6 is 5, right? Because 6 goes into 6 one time. 1 times 5 is 5. 6 times 3/2. 2 goes into 6 3 times, so 3 times 3 is 9, so it'll be minus 9. And again, if you're having difficulty with fractions, you can multiply 6 times 3/2. You'll see that you do get 9. Okay? And 6 times 7/3, 3 goes into 6 twice, that's going to be 14. 2 times 7 is 14. Okay. Then you can solve the equation without fractions, so you're going to add your 9 to both sides. So you've got 9 plus 14 is 23. So 5k equals 23. And then you can divide both sides by 5 to get the k by itself. And you'll see that you do get, again, 23/5. Okay, so I've got the same thing, which is good. And again, both methods are fine. I can either just force myself to work with the fractions through each step, or I can clear the fractions to get rid of them. Okay, let's move on to part G. In part G, there are a couple distributes to do. So we're going to have 7 minus 2 times 5 times 2 times 4. So that's 7 minus 10. And then 2 negatives are going to make that plus 8x equals, I've got my 3x and just a negative there to distribute. So minus 8x and then a negative and a positive to make that plus 3x. So let's do some combining. 7 minus 10 is negative 3 plus 8x equals 3x plus 3x. Combine those, you're going to have 6x. Oh, minus 8x. So I could have done all of those. I didn't notice that one had an x. So let me just make that minus 2x. Because 6 minus 8 is negative 2. Oh, never mind. That didn't have an x. There was no x there. My bad. No x there. So let's try this one more time. That would be 3x, and 3x is 6x like I thought, and then minus 8. Okay, that's a little better. Okay. I thought it was unusual. I had an x, so I had to go back and check. So let's look at this again. I've got negative 3 plus 8x equals 6x minus 8. There we go. Now I want to get the x's on the same side, so we'll subtract our 6x from both sides. It's going to give us negative 3. So I'll move this to the front in a minute. Plus 2x equals negative 8. And then to get the 2x by itself, we're going to add 3 to both sides. So 2x equals a negative 8 plus a 3 is going to be a negative 5. And you can divide both sides by 2 to get x equals negative 5/2. If a number doesn't go in, keep it a fraction, and you always want to keep your fractions improper instead of converting them to either decimal or mixed number. So negative 5/2 is the answer there. Okay. In part 8, our last part here, it has fractions again, so I'm going to use the clear the fractions technique. I'm not going to do this one both ways. We're going to clear the fractions. And we're going to clear the fractions by multiplying everything by the least common denominator, which is, for 6, 8, 3, and 4, those numbers all go into 24. So we're going to use 24. Okay, so we're going to take 24 and multiply it by everything. So I've got 1/6 x minus 3/8 equals negative 2/3 x plus 3/4. All of that times 24. Your calculator can really help you out right here. You know that 6 goes into 24 4 times. That's going to be 4 times 1 is 4x. But if you're having a little more difficulty with your fractions, just go ahead and multiply 24 times 1/6. It's 4, so you have your 4x there. Okay. I know that 8 goes into 24 3 times, so 3 times 3, that'll be minus 9 there. 3 goes into 24 8 times, it's 8 times negative 2, that's going to be negative 16x here. And 4 goes into 24 6 times, so 6 times 3 is going to be 18. Just one more time to check if you're not as good at multiplying those fractions together. Just that last one is 24 times 3/4. So once again, you can see that you get 18. You can use your calculator to assist you if you need it. Okay. Now we're going to get the x's on the same side. We've got a negative 16x. That's the smaller value. So I'm going to add 16x to both sides. So that's going to be 4x plus 16x is 20x. Minus 9 equals 18. X's are all together, so we're going to add 9 to both sides. So 20x equals 27, and then divide both sides by 20. There's no number that goes into both 27 or 20, so we're going to just leave that as our answer, 27 over 20. That fraction can't be reduced. And that's the end of Part A.